Hello and welcome back to the third part of the webinar called IP Fundamentals for Pro AV Professionals. I'm Tibor Fejes and I'm the host for this event. I'll be staying in the background, monitoring the session and answering the questions. And today, as in the previous two episodes, our presenter is going to be Gábor Kocsis, who is a technical trainer, and he has been teaching IP for the past 20 years. So while we wait for some people to join a few minutes late, let's quickly cover the usual mandatory housekeeping items. First of all, depending on what type of device you're using, you can see Gábor's webcam and his share screen next to each other or on top of each other, and you can grab the line dividing them and manually resize one or the other. And if you're watching on a smaller screen, like a smartphone, then you can watch only one thing at a time, so you can swipe left and right between the webcam and the shared screen. Secondly, by default, all the attendees are muted, as usual for webinars, because we might have hundreds of attendees. But you have a way of communication, and that is the questions panel. So if you have any feedback or question regarding any of the topics that Gábor is going to talk about, please feel free to use that questions panel and send us your comment. And if we have some basic technical questions, then I will be answering those in the background. But if we have questions which are interesting about the topic and we think that many people should hear the answer to, then we will keep those questions until the end, until the live Q&A. And I will read out loud those questions, and Gábor is going to give you an answer. And lastly, I would like to assure everybody that this webinar is being recorded and it's going to stay on GoToWebinar server indefinitely until we decide that it is no longer relevant or until we have a newer version of the training. And you will receive an automatic follow-up email after the session ends, 2 hours after the session ends. And that email is going to contain a link to the video recording. So rest assured that you will have the recording if you want to watch this event back anytime. So we are 3 minutes in, so let me pass the word over to Gábor, and he's going to walk you through the third part of our webinar series. Gábor, the stage is yours.
Thank you, Tibor, for the introduction. Hello, everybody. Good morning and good afternoon, wherever you sit. So as Tibor mentioned, today we're going to go with session 3, and today we're going to look into network devices like the switches, routers, and we're actually going to look into two interesting functionalities, the gateway and the firewall functionality that you find in router devices. Now, of course, a little bit of a recap from the first two parts of this webinar series. Because of the bandwidth we use in our products, we are actually surfing, luckily we're surfing the complexity waves in networking, and the majority of the complexities the IT companies have to deal with because they are the ones who have to keep the network running. And because of most of the complexities that they deal with are not relevant for us, we don't actually need to deal with right now, especially not in a first step training session like this in fundamentals. Now, a little bit of a recap what we learned in the previous parts. We actually talked about the building blocks of network communication, like IP addresses, port numbers, subnet mask, private and public networks, how the communication goes between devices, where the IP addresses come from, and of course features and functionalities that are important for the AV industry, like a VLAN, multicasting, link aggregation, and so on. So what we're actually going to do today is we're going to bring all these things again together to explain a number of things that are really relevant for us. First and foremost, how the IT infrastructure is impacting the AV industry. And we're going to look into differences between layer 2, layer 3 switches. Actually, we're going to talk about managed switches and unmanaged as well. Then we're going to look into the general difference between a switch and a router. We're going to look into what a router really does, and we'll see how it helps or hinders us in our work. And then, as I mentioned, we're going to look into the basics of gateway and the firewall functionality. Now, of course, first we need to understand the background of today's topic. Why do we focus on these devices? Well, first, our clients, who are the end users of the AV products, they need to make some sort of a financial decision when they need an infrastructure to communicate video and audio signals. with the network. So what happens is they typically have their existing IT infrastructure, or they're building their IT infrastructure, and they already say that they have a high bandwidth network. Now, of course, we understand the argument if they would like to use that, and we understand both sides of the argument. What are the benefits of having a dedicated network, or what is the consistency or a condition of using their network that they're installing. So what we want to do is we want to deliver the AV signals with high quality, and we want to do it fast. So our industry and our work is going to be actually judged based on the video and audio signals that arrive on the other end. It's not the network speed that's going to be judged, but how we do our work. So this is generally the basics. And in the technical background, actually what happens is the large networks, and actually any major corporate network, uses something that I would call a redundant path complex system of routers. And we need to look into what that means for us. Because anybody who says that or suggests to us that we should send our AV signals through their router devices, for example, and share their trunks to communicate, we really need to understand the consequences of such actions. Now, bandwidth is one thing. That's generally a number. However, guaranteed bandwidth and reserved bandwidth is a completely different story when we're talking about our signal latency. And this is exactly where the entire infrastructure comes into play, not just the devices and their own internal latency parameters. So we're going to focus on the entire system today. Let's do a little bit of a general overview on the hardware first and go a bit into the history. So a long time ago, there was something that we used to call a hub, which is really history now. It used to be a data replicator, and it could only broadcast. We mentioned this before, but it's important to understand that this device was a long time ago acceptable, and then it became obsolete because it was too slow, had a lot of problems. And then the industry came up with the switch, which is a distributor, and this one actually was something we call right now an unmanaged switch, which had hard-coded intelligence. So it had some features, but they were valid for all the ports at the same time and all the time. They could broadcast and multicast and unicast, of course, but it depended really on the level of intelligence they had, especially multicasting. Now, after a while, then the managers came about, which are, again, distributors like the regular switches, but they are actually configurable. So they have additional knowledge in it, like an additional processor. And what they do is they allow us to configure all the parameters. Well, pretty much every functionality is programmable in such a device. So they also do broadcast, multicast, and unicast, but it has its own IP address, and it can actually do a number of things that a regular unmanaged switch cannot. And of course, something that we've talked about before in the previous parts, a router, which is technically a data forwarder. It's not a distributor, but it's most of the devices you find on the IT world right now, and if you buy something in a store, they are actually combined with a managed switch. So you have a router and a managed switch built in together, and they are actually connecting to those networks as we talked about before. So they do have those private and public IP address and physical sites. So this is important to understand. These are the four general types that we're going to focus on. Now, of course, during these training and webinar series, we had questions about using unmanaged switches. So what we'd like to do is we collect the reasons or questions what you need to ask before you look into using an unmanaged switch nowadays. So you ask, do I need the following things in my network? Do I want to link switches together with, let's say, the uplink or a trunk or a balanced uplink, I call it? Do I need an IGMP query function to actually do shared multicasting functionality amongst these switches? Or do I have like a Dubex product when we need to do link aggregation of two ports? Or do I actually need a VLAN or multiple VLANs? Well, if any of these answers are yes, then all of these functionalities will actually exclude all the unmanaged switches. None of these functionalities can be done with an unmanaged switch. Now, if you say no to all of these questions, then you may have a chance. So let's see what kind of things you can do or what kind of unmanaged switches you can use. There are basically two functionalities that you look into. If an unmanaged switch can do IGMP snooping in V2 functionality or version 2 functionality, and it also supports jumbo frames, which is actually a kind of a hint for what the limited use case of such a device is. then you may be able to get away with an unmanaged switch. Now, there are features in an unmanaged switch like QoS, which is practically a prioritization process of giving some computers a higher priority on data traffic over others. Or we have, let's say, the loop detection or bandwidth control. These functionalities are nice, but none of them will actually help us. They will not do anything for our industry, because we always need the highest priority. We always need the bandwidth, the full bandwidth. And in our infrastructure, typically there are no loops. Loop detection is for structured environments. Now, there are something else actually which is quite important. If you may have not realized yet, but some of you may already seen this, that we used graphical user interface screen captures in this training before, and actually we're going to do that in the next 2 sessions. We're going to heavily use graphical user interface on managed switches, and those are very important for us when we want to see what happens on the network and we want to troubleshoot something. Now, any of the features that you've seen before or actually going to see the next 2 parts are unavailable if you use an unmanaged switch. So if there's a problem or any kind of a troubleshooting you need to do, you're flying blind. You're not going to see anything what's going on the network. And there's one actual functionality that we haven't used yet, but I'm going to show you in the next 2 parts, which is called port mirroring. This is such a building block, or a basic building block of IT administration, that in managed switches, this functionality is in the basic part of configuration. This is one of the first things IT guys use when something's wrong on the network. And of course, this is also not available in unmanaged switches. So it's important for us to understand what a managed switch will do and what an unmanaged switch cannot do. So if I want to pull this all together, if I have a very small AV over IP project, for example, a Vinx video wall, which only uses one switch and nobody else is actually on the same switch, so we don't have to separate ourselves from anybody else. You may have one computer that has the LDC software to configure the devices, but you're not sharing with anybody. And you do actually support these 2 functions that are mandatory, the IGMPv2 and the jumbo frames, which is, by the way, because it's not configurable, it is enabled in every port by default. Then you're going to be able to use, in these very small, very isolated examples, an unmanaged switch. Of course, if you have any diagnostics to do or anything to do on the system, you're going to be flying blind, as I mentioned before. Now, the other thing, of course, is the different layers in the layer 2 and layer 3 switches and what they do. So let's look into what these switches do and what's the general difference. Now, the typical switch, as we talked about before, it's just delivering traffic between computers inside the network, and it's actually supposed to stay local, to stay within that network. And most typical switches, and with typical I mean layer 2, they are actually operating on the MAC address level. So they're really just trying to make sure that the packets are delivered fast and they are not generating unnecessary traffic, which of course is a question what unnecessary means. And they don't have an IP address, so if you want to communicate to them, you can't. Now, the other thing is that a bit of a history on that, because when networks became faster, layer 2 switches were actually not enough anymore for the IT departments. So there was a problem because some of the security policies required a router functionality, and routers actually slow things down because they have those hops and those redirections we talked about. So that was an issue. And there are other technologies outside of security policies that also required layer 3 functionalities like IP-based delivery. And actually routers can do it, but they are slower and they are actually designed for a completely different purpose. They were not switches to distribute packets. Now, of course, there's one thing we need to always note is in today's speed in the development in the IT industry, we don't know how long this term as actual, these statements will actually hold through. 6, 12, 18, whatever months from now, IT companies might come up with a router that is as fast as a layer 3 switch. Really hope that they do. Now, what actually happened in reality is over time, layer 2 switches, because of these requirements, they started to look like the hubs used to look 10, 15 years ago. They were very slow now for the new requirements, and they had a lot of errors in the network packet. So what the IT industry really did is they said, okay, we need the functionality of the router. And there's all the IP-based deliveries and all these security things. So, but we need a device that does it and it does not slow things down. Now, this is actually what the layer 3 switch is really, a high-speed network switch that has some of the router functionalities, and we prefer to use these devices wherever we can. Now, of course, in our industry, we know what the word slow and slower means. We have calculated consequences when we have a slower connection. We have to forcefully use lower screen resolutions. We have to use subsampling. We have to do some sort of a compression technology. But there are also consequences that are not calculated. Those are frame delays, and we're dropping frames, or signal quality issues, and we have pixelation. And these are the kind of things that actually will upset our customers and will upset us as well. Now, let's talk about this latency and frame delay a little bit. Now, there are certain numbers. For example, Wings has a 1.1 frame latency when it's processing, and the UBEX has 16 lines of latency. But everything else that comes into latency picture is up to the network. So if we share an infrastructure with somebody, the same customer has different networks, and we share the bandwidth with them, then the performance we have cannot be guaranteed actually. So if we have a dedicated network, then we can eliminate all the outside influences on our network. Now, if you look at the screen and see that UBEX has 16 lines, that's a 1/10 of a millisecond. Later, you're going to see some millisecond numbers on screens. You can imagine how much latency certain devices can add, especially routers nowadays. Now, as a kind of summary, so what layer 3 switches really are, they are advanced switches that are above layer 2. They can actually look into IP addresses. Now they can do special policies. They reduce broadcast traffic, which is one of the biggest sources of network noise, if you will. Unnecessary communication between subnets on the same network switch. And of course, the security rules when they allow unblocked traffic. They're of course a lot faster, and they can manage VLANs, which is really important for our industry. So these are the general differences in these switches. However, of course, we need to talk about something that today we're not seeing, we're not using, but we're getting more and more requests from customers when they have routers on the systems. We need to look into that. Now, in the first part of this webinar series, I gave you a riddle, and in every part of this series, I'm giving you the reminder slide that we're not going to go in depth into the network details, and we're going to surf above the waves. Now, everything that was about these images and the riddle has something to do with the multicast routing functionality. And I mentioned this because we knew how complicated this could be. IT world exactly knows how complicated it is, and they can actually really struggle sometimes to keep their system running because of the way how routers communicate and the way how they find their way in the network when there are communication problems, links that are down or links that are congested, a lot of traffic on different wires, and they have to go around. This is something when you see is a redundant path network, and those routers actually can do a lot of unnecessary traffic, especially with multicast routing. So it does affect our industry a lot if we even consider putting our data on such a network. Now, as usual, or as from the first two parts, I gave you something to try so you can actually experience it on yourself, because there are actually certain things that you cannot really access. We can as manufacturers, but you may not have the ability to do certain things, and it's not your personal ability, it's the access to certain things. So what we're going to do is we're going to illustrate the network communication with the internet, and we're going to see how large networks can impact us. Now, remember, internet and wide area network is not the same, and we do this because of two things. First, corporate networks operate pretty much the same way, the same concept and the same principle. The timings are different. Corporate networks are faster than the internet by nature. And we actually do this because you cannot just go out to a customer and you poke around. You cannot poke around their network. You can't sniff in with a software and see how they work. You're not going to be allowed to do that. So let's try and understand how those networks work by using the internet as the basic example. Now, what I'd like to ask you to try is following the first two parts when I gave you the traceroute functionality, how to use and how to find out how a network packet will travel on the internet. And I gave you the TTL feature with the initial number change. So what I'd like to ask you is when you have some time in the next couple of weeks and different days and different times of the day, use these two functionalities to find out how far one of your favorite, preferably international website is from you, and do the same functionality. Let's say use the initial number 8 for the same server and see if it always going to be the same number of hops. And when you collect this data, just compare it and see what are the differences in the different packets at different times and different days. Now, what's going to happen actually, when you have these networks and these multiple routers are working, you're going to see different timing parameters. You're going to actually see cases when more hops and more steps are needed to reach the same site. And you're going to also see cases when the server or router that was in the list before, it's no longer there, and you see some new devices appearing on the list. And this is actually happening because these routers and these complex systems are dynamically picking the best route for their packets. This actually means that if you're connecting, you're not getting the best route at all times. They are giving you the best at that moment, which could be 10%, 20% slower than you had a couple of minutes before. So this dynamically changing nature of large networks is what will have a performance issue on any device, especially that's when we are streaming AV signals live. So there are a lot of things that we cannot tell, and internet and large networks are used by humans, and we have the nature of being unpredictable. We don't know when 100 people will download something at the same time or join a large conference and start using data networks that slow certain trunks or cable cores down. Now, in part one, I actually gave you a visual, but I didn't call the details out at that time. Just mentioned that when you, let's say, trace route lightware.com or microsoft.com, then you may see different things. So I actually did this screen and I did the trace route function on those two websites within about 2 minutes. What happened is when I did the lightware.com, my computer went through 2 servers in Budapest to reach the destination. And 2 minutes later, another computer appeared in the list, and the MON.HU-MON server is actually further away from Budapest where I live. So I went further away and then came back in. So within 2 minutes, the network decided that the optimal path is no longer directly to the city, but it's away a little bit and then come back. Now, of course, I did something else. A couple of weeks later, I gave a try to the same website. It was Microsoft.com. And very early in the morning, a couple of days ago, I did a trace route. So what happened is a few weeks ago when I did the first capture for the first part of the webinar, I needed 2 steps in the Hungarian servers to reach the Austria-Vienna server. And early in the morning, a few days later, I only needed 1. So actually, instead of 9 steps, I got through to the Microsoft.com website in 8 steps. And if you look at the timing parameters on this screen, all those milliseconds, there are a lot shorter time frames early in the morning when most people were still sleeping, like 4 o'clock in the morning in Budapest. So I could get through to the same website a lot faster. And this is, again, unpredictability of the network use. This is what internet devices have to do to deal with these kind of complexities. Now, I did something else just for you guys to understand the what geographic distance and best route is, or best path. So I did a trace route to Cisco.com because Cisco is located, that server is located in Texas. So let's follow the geographic route of what happened. In the first 5 steps, I was staying in Hungary, and I was actually inside my service provider's network in UPC International. And from there, I went to Frankfurt, Germany. And I was there for 2 hops. And actually, the next step, I came back from Germany a little closer back to Hungary. I stopped over in Czech Republic in Prague. Then from there, I went to Washington, D.C., was still in the same service provider's network. And from Washington, D.C., I came back a little bit closer to Hungary, to New York City. And in New York City, I actually exited the service provider's network, and I went down to New Jersey, where I entered a different network, which is AT&T's US core communication network. From there, we went to Georgia, and then we went to straight to Texas, and we entered the Cisco local network. And this is actually how the geographic distance and the path and the network path can differ. So there are certain things in a network you cannot change because you are in one service provider's network or one subnet, if you will. and there is only one direction to get out of there. So you have to go to the place when you can get out of the network. Then there will be, let's say, between two buildings, there will be a fiber optic core. You always have to go through that. And then you're going to have another chance on the other side to pick your route, let's say, in another building between routers. So some things will change dynamically, but some things must stay the same. This is exactly the same with corporate networks. Now, as a summary, if we consider, or before we even want to consider a router anywhere on the network, we need to immediately clarify with the customer's IT department, because we need to clarify the bandwidth requirements, because our products need the performance to deliver while we're actually there in the building. Our customers need the fast video and audio signals. And what happens is, in most likely, they will have the physical infrastructure there, but they cannot actually guarantee the performance that we need for our devices. So if they say, yes, we're going to give you always the same route, the same two devices, and we're going to dedicate something to you, that's no longer the same network. You have a dedicated network inside a network, and it's not really different than having a switch, because if they want to guarantee something like that, they will separate switches for you, and they will separate cables. So technically, they create exactly what a layer 3 switches in a dedicated network would. So they're no longer using the same infrastructure. Now, of course, besides these basic functionalities of what routers do, they have also other functionalities. In fact, the home router that you use have a number of additional features. We need to look into what they do, because we typically don't need these functionalities, but routers do actually do certain things on the network unexpectedly. Now, one of the things that we talked about is when you want to restrict, for example, which device can go on the network, then these devices can actually create a list of MAC addresses and say, if the MAC address is not on the list, I'm not going to let it through. The other thing is, a lot of cases, even at your home, your router is typically the DHCP host that gives you the IP address. And it's the same device that will give you the reserved IP address, let's say for a Lightware product, if you want to communicate between two devices with the Lightware 3 protocol. And of course, other things like quality of service, when they do some prioritization of network packets. Now, these are basic functions, but none of these are really useful for us. We need an IP address, but other than that, they may actually cause issues on the network. So let's go and look into the two functionalities and gateway and firewall functionalities inside this router, and let's see what they can do that can impact our performance. Now, as we mentioned, of course, routers deliver these packets between networks, and they somehow block the unwanted communication. But this is the unwanted, what we need to clarify. So, but for today's training, actually, what I'm going to do is I'm going to use the two different sides of a router device as a gateway for the private side, which will let us out of the network. And I'm going to use the term firewall for the public side of the router, which will actually restrict or protect us from the outside world. Now, in reality, there's a lot of gateway and firewall functionalities on both the wide area and the local area side, but that's something more for the IT world to deal with. Now, in order for these devices to communicate properly, and this is something we talked about in the first part, this gateway and the firewall side must actually work together. Now, one of the analogy I used is when we want to get to some packets to the network, we talked about how port numbers are used and how the network devices actually remember those port numbers along with the IP addresses. So somehow they remember that we've seen this kind of communication in the network before. Now, the example I used, and I'm going to stick to these examples, if you request a packet or an information from the internet, then you're sending out something, and when the response comes back, the system will remember that it is a response to something from your computer. And this is, of course, what internet is for. Now, port numbers and those IP addresses will be the ones that are helping the gateway and the firewall to do this. And this is actually how this functionality is done. So the two parts or the two sides are working together by storing and looking up those numbers. Now, let's see how does it impact us. So when we run into any sort of a network issue, and if we're not using layer 3 switches that are dedicated to us, we're going to have some limited opportunities for troubleshooting. There are a couple of things that can happen. First, there might be policies in those devices that you don't know about. let's say a MAC address list is created and your UBEX or Wings products MAC address is not in it, and suddenly nothing's going through. That device is not allowed to be on the network for some reason. Or there may be some features, I'm going to show you a couple of them, that you may have never heard about or not used before, and you might misinterpret their functionality. And there are, of course, other things that devices generate event logs somewhere, they being stored somewhere, but you cannot see them. So in these cases, what happens is you need to go to the IT department to try and find clues of what's going on, because those things are actually invisible to you. And one of the things that I'm going to actually do in the next two parts is I'm going to show you the Wireshark network analyzer software to visualize how the network communicates. However, that software is very often forbidden on large networks, and almost every corporate network is forbidden to use actually, because it's a dangerous thing for data privacy and security. Now, if there are issues like creeping or disappearing, or if you call them wandering issues in the network, then the first thing is if you have other devices, let's say devices other than layer 3 switches that are connected, then there's a couple of things you will see. You may see like devices inconsistently communicating, and let's say devices appearing and disappearing. They communicate and they stop communicating. Or you may not see actual obvious signs of a network issue. Let's say the device is not completely disconnected. It does something, but it doesn't seem to be doing it the right thing. Or you actually see devices do things that you don't expect. You expect an LED to be steady, and it goes steady, and then it goes flashing, and steady again, and flashing, and this seems to be illogical. And of course, as I mentioned, we may not actually have tools to actually troubleshoot this system. Now, I'm going to show you in the next two parts how to do those things, and you're going to see live how to make use of these softwares and applications to troubleshoot what's going on the network. So really need to be aware of what could happen to the data that we're using when we are sharing communication channels with others. It's really, really critical for us. Now, let me give you an idea for a remote connection opportunity where we can actually use routers. Now, this is an example from a real case when a customer was really far away from their installation, and they're actually the service company had to travel several hours across the country to do a service. And this is something you know, of course, because on the traditional AV business, you would have to go to the site to fix an HDMI connection or device or something. However, with AV over IP, you can actually do this remotely. And the opportunity there was to actually reduce the cost of traveling, going back and forth to the site, because installing a workstation at the site was a lot cheaper than going back and forth with the technician who was supposed to be installing different projects instead of not going to the site, changing things or analyzing things. So if you have a network switch, let's say with two, let's say Wings products, AV over IP products, and you separate them in a special VLAN, like VLAN number 2, both in a workstation and in a switch. And on the other side, when you have VLAN 1, you can actually reach those computers from the outside, whether it's the computer itself or the network switch. You can go and manage those things. And you would not be impacting how the AV over IP products work, because the VLAN would completely separate the router. So the router would not have any impact on the device. Now, of course, there's an opportunity. The moment you have a computer there, you can use applications like the LDC software. You can remotely access, and you can actually go and configure and look into parameters of the device without going on site. And in order to do that, we would do something that I call static routing or port forwarding. And this is a technology where we can actually reach devices remotely. Other than what you may typically know, like applications that will go initiate the communication from the inside and let somebody back in, which is the standard functionality of firewalls like internet. We go out and we get the response back. And that's like TeamViewer and those applications when they are initiated from the inside. Now, we can initiate messages from the outside, but of course the rules will be defined by the IT administrators. You can do the connection through the switch directly, so you can go into the managed surface of the switch, the console, or you can actually go directly into the workstation and you can reach the switch configuration from there. And of course, from there, you can also do the AV over IP product configuration. And of course, the separate VLAN is a mandatory thing. So this is something that you might want to consider if you look into how many times you have to go to a site just because something does not seem right. Now, looking into a bit more in the details of the gateway and the firewall side, the gateway is actually simple. We've talked about this device a number of times in both part 1 and 2. So it's a door to another network. And of course, the IP address and the subnet mask are the functionalities or the features that actually make this part work and determine if some packet is staying on the network or going outside. But I'm giving you a new term actually, that the IT guys use. It's the IP masquerading. We talked about this in part 1. When you're communicating with your laptop and going to the internet, then the router is going to change your source IP address and is going to send it to the network because your private IP address is not valid on the internet. What happens actually is that if you have multiple computers that are coming from a network going to the internet, with this change, with this IP masquerading, the router will make it look like that there is only one device on the network. It's going to actually hide the devices because all these source IP addresses are going to be from the router. So for the internet, it looks like there's only one device. However, what we need to look into a little bit more is the firewall side. Now, right away, I'm going to give you 2 functionalities because these are the typical things that if you are not familiar with these features, you might misinterpret their functionality. They work properly and they look like something's wrong on the network. The first one is disabling the ping reply. A lot of cases, people try and verify the network connection by pinging devices. Now, if that particular device has any security or performance reason to not allow a ping to be replied to, so when we're pinging something, it's not going to respond, then it's just simply going to look like it's not there because it's not going to have a response. So you might think the computer is gone while it's still there. It's just using this feature not to let anybody try and find out that it's there and try to get around its security. And the other functionality we call MAC address cloning. I mean, you can actually change the MAC address of a device. Most cases, these devices have burnt-in fixed MAC addresses or serial numbers, but in a number of devices, you can actually change it. So it's going to actually allow the computer to appear like it's something else on the network. Let's say if you have a Cisco router, you can change it to make it like it's an HP laptop, or you can make it look like it's a Lightware device. So just by looking at the MAC address, you're not going to be able, or not necessarily going to be able to tell what is sending the message. And a lot of cases actually used. In part 1, I gave you an example when there is actually in the appendix slides, there was a virtual IP address structure. When one device, the gateway, is actually 2 different devices, and you are only talking to a virtual address, and 2 devices are taking turns on who's responding to you. They would actually act like it's the same device. So those devices would be having the identical MAC address, but they would never sit on the network at the same time. So you would not know which device you're talking to. You'd think that you're talking to the same MAC address. So there's a lot of functionalities actually that these things are used, but they can be misinterpreted easily. Now, of course, the other thing is the core functionality of the firewall. So as we talked, if there's a message coming from the outside, the device is protecting your network. So it's going to actually look into some tables, find out based on some rules if the packet that's coming in, it's allowed or rejected. And based on these rules, it's going to actually typically generate a log. In most cases, it's enabled. In your home router, this functionality might be actually turned off. But what happens is any incoming traffic is actually logged on these devices. So if something's unexpected or unwanted, then the IT departments can find out that it's probably a threat or a denial of service attack or something like that. Or maybe something that we want to get in, but we did not set up a rule. Now, there are, of course, 2 parts what we talked about. If a response to a request is coming back in, then of course the device is looking into the IP address and the port numbers. It's going to find it in that port address translation table we talked about before. And the firewall will know who sent the original request based on these numbers and send it back, send the response, actually route the response to the correct computer. Now, if an unknown packet comes to the firewall, then the firewall is going to look into something else. I call it an inbound routing table because that packet needs to be routed and it's coming in, so it's inbound. And there are other security rules that need to be created. And we're going to actually call this static routing, as that's the general term people refer to it. Different brands may use different terms for this same functionality. We're going to actually use a very simple example. Now, imagine that we have a computer network where we can flexibly set up rules. And in that network, we have 3 web servers, and they are behind the firewall. And these 3 web servers are listening to the classic HTTP port 40, or let's say HTTPS port 443. And what happens if there are messages coming to the firewall, if they would all come to the same port that those computers are listening to or looking for, the firewall wouldn't know what to do with them. So what you can do is you can actually set up a rule to say, if I get something to the firewall on port 80 as a destination, I'm going to send it to computer number 20, and I'm going to keep the port number 80. And if something comes to 10,080, for example, then I know that this is something that I need to send to computer number 30, and it's going to be actually going to port 80. So I'm going to change the destination port because that's where the computer is waiting for this request. And of course, the same concept, if you have, let's say, 20,080 is the destination port number, then I'm going to route it to computer number 40, and then the port would be 80 as well. So this is, again, how the 3 different computers would get their appropriate ports and the destination. Now, in part 1, you probably remember we used the train analogy, and I mentioned this train that interestingly changes its from and to labels at different times. And we had this issue that how the destination would know which platform to send the train. Well, and we said that the answer was port numbers, and we said network address translation. So this is actually pretty much what the firewalls do when they let in packets. If the original request was not coming from the inside, but it was actually a original request coming in. So the one packet that comes in, there's no source from the inside. Now, let's see this visually. If I have this computer, and you've seen this visual before, at least part of it, when we have a request coming in from, let's say, one computer or network traveling all the way through the internet, it hits the router and actually the firewall side of the router. What happens in this firewall is going to look into where it's coming to. What is the destination port number the original request sent? If it's 80, and as we discussed, it's going to go to computer number 20 on port 80. If it goes to 10,080, it goes to computer 30, port 80. And in 20,080 is going to be switched to computer number 40, and it's going to be port 80. And actually, that's how the packet will be delivered to those different computers, and that's how you can actually, from the same computer, from the same internet browser in 3 different windows, ask 3 different websites behind the same firewall to deliver messages to you. Now, you can actually easily do this because when you set up an IP address communication in your browser with the colon function and the number after it, that's the port number, you can tell exactly what port you want to talk to, and the TCP communication, let's say, for web servers would be the same. And what I'd like to give you is a screen actually from a real Cisco Linksys router firewall part. In this case, they call it the app and gaming functionality, and they do this like a single port forwarding, which is in most cases is called static routing. And that's exactly what I set up in this device. So you can see that the standard communication is, if it comes to 80, it stays 80, and I'm going to forward it to computer number 20. 10,080 goes to port 80, but it goes to a different computer. And 20,080 goes to port 80 again, but it's going to the 3rd computer. Now, in real application, imagine if the first computer is not a web server, but this is the computer that you set up behind in the customer's network, or the device number 2 is the network switch, it's management console. Then you can actually get to it, and with these security policies that the IT guys would help you set up in an environment, because they actually want to set up the rules of security, they would be actually able to help you get inside a network. And in this case, you don't actually need somebody on the other side to let you in, to, let's say, send you a TeamViewer request from the inside. You would be able to actually get into the network from the outside. And with this, we reach today's general subject. So let's see if we have questions.
I love the webinars you do. You just completely fry everybody's brain. So we don't have any questions, but sorry?
I'm trying not to.
But this is usually the time when people start grabbing their keyboards and start typing questions. So hopefully by this time, after watching all 3 webinars, you know everything, or you're at least familiar with all the concepts that you need to understand in order to design or troubleshoot AV over IP systems. Most likely for troubleshooting, you need the IT administrators on the network, as Gabor explained. But in part 4 and 5, you will see some real-life examples. So we will have a demo in the 4th part about Wings, and in the 5th part about UBEX. And Gabor is going to show you some really interesting stuff. So this is not going to be a product introduction for Wings or UBEX. We expect that you know about these products, you know how they work, and these are mostly going to be about interesting facts related to designing Wing systems or UBEX systems. All right, in the meantime, we get a message. So, is it true now that layer 1 and 2 switches are just not used for anything since level 3 are so plentiful?
Well, layer 1, the hubs are really not used. Layer 2 switches are used in a lot of cases at home in small applications, not in the AV industry, but layer 3 switches are really what they allow us the performance to do. So more and more the layer 3 switches are becoming standard in large applications. Generally, when you have to separate multicast communications and you have to create VLANs, is when you need layer 3 switches and managed ones. So that is where the large bandwidth, let's say if you have a trunk of, let's say, UBEX communication and you need 40, 80 gigabits per second on the same core, you need multiple cables, and those are the switches that actually do that. So all the complexity and the high bandwidth would make the layer 3 switches standard nowadays. Layer 2 switches simply cannot do the job unless you use a tiny system like I explained to you with the Wings video wall.
Yes, and some companies, or at least one company, started manufacturing a matrix especially for Pro AV applications. So their default settings are what are required for a Wings installation. So it's a good thing to see that switch manufacturers are starting to consider Pro AV applications, and they're designing products for our applications.
Correct.
All right, from the same person, regarding AV packets, can we literally tell routers to always send them through a specific path?
Well, technically, that's what we're doing with the IGMP query and the IGMP snooping functionalities. We're going to show that because I'm going to talk about what a UDP packet is and how the communication goes. But since you have network switches, it's going to always go to the same path, as you're not creating redundancies and you're not using routers. So there is no other way for the packet than just the one connection, let's say, even if it's multi-core, but it's the same connection at all times. And that's the benefit of having only switches, that you don't have to go around devices, because it's the path is always guaranteed and the bandwidth is guaranteed as well.
Okay. No more questions about these topics so far. So I'll start wrapping up, and if any question comes in the meantime, then I'll stop and I'll ask the question. So thank you for everybody for joining us today. I hope it was also interesting enough for you. And I hope most of you are interested in part 4 and 5, which are going to be about these products. If you would like to learn more about these products, then please go to www.lightware.com, or you want to learn about these products before the webinars, in case you haven't used them before or you haven't heard about them before, then you can do a quick research to see what Wings is all about and what UBEX is all about. And when you watch Gabor's webinars, the last 2 parts, then you will be familiar with these products. In the meantime, we get another question. Can we review the material from parts 1 and 2? Yes, I'll mark your email address and I will send you the links to the recordings of part 1 and 2. And you will get an automatic follow-up email after this webinar, and that's going to contain the link for this part, the 3rd part. So if you have any questions about the topics that Gabor mentioned today or in the previous 2 episodes, feel free to send us an email to training@lightware.com or support@lightware.com, or reach out to your local Lightware representative and you can start a discussion. When the webinar ends, you will be prompted to fill out a survey, and one question is about whether you want to receive a demo unit, a Wings demo unit or an UBEX demo unit. Unfortunately, because of this pandemic situation, we cannot visit you, or our offices cannot visit you, and you cannot come to our office, but we can certainly send you a demo unit for a few weeks in case you want to play around with them. So if you do want to play around, then please tick those boxes in the survey. And the other questions are about this webinar, how you rate the content, what you like the most, how you would think we could improve this material. So if you have a minute to spare, we would really appreciate it if you gave us your feedback. We are always looking for ways to improve the material and the way we deliver these materials to you. So if you have any thoughts, please let us know. We don't have any questions left, so it's time to say goodbye. Again, if you have questions after the webinar, just send it to us and we will reply. But that was it for today. Thank you, Gabor, for doing this 3rd part, and thank you for everybody for joining, and we hope to see you in the 4th part. Bye.
Thank you. Bye.